but let's get cracking on compound angles. So in our first lesson the other day, we just revised basic trig, grade 11 trig, should I say. We spoke about reduction formulae, we spoke about the cast diagram, etc., etc. And if you recall, I was explaining to everybody that compound angles and double angles are what's new in matric, but the questions remain the same. So they still ask you to work with Pythagoras and ratio in terms of a letter and identities and equations, but the compound angles and the double angle formulae then come into play in all of these things as well. All right, so yeah, that's why we're going to focus on compound angles and double angles first, and then we'll start doing the sorts of questions that you can expect in tests and exams that include these things, as well as the grade 11 work that they expect you to know. All right, so the compound angle formulae, it tells us here sort of quite formally that compound angles involve a trig ratio of the sum of two angles or the difference between two angles. But what really does that mean for us? It's a little bit difficult to understand these formal definitions. So let me just show you what it is that they mean when they talk about the sum of two angles or the difference of two angles. Let's just draw a Cartesian plane, and then I can explain what that means. And I want to draw another Cartesian plane, so I'm just going to do that now while I can. Yes, black was good. Okay, and another Cartesian plane over here. All right, okay, let's go and get a different color. So if I go, so this is what a compound angle is, right? So in other words, my terminal arm is anchored at the origin, and let's say I start rotating it in an anti-clockwise direction, and I obtain theta. If I was then to rotate it further over to the left-hand side, so let's say now I rotate it even further to the left, I go plus 30 degrees in an anti-clockwise direction. This entire angle is seen as theta plus 30. Okay, so that is a compound angle. Okay, the sum of two angles. All right. When we talk about the difference between two angles, again, our terminal arm is anchored at the origin. It's lying on top of the x-axis. Let's pretend I now go up here, and I have gone alpha degrees in an anti-clockwise direction. Now, if I change direction, and let's pretend that now I come closer back down to 0, so I reduce the size of this angle, and let's say I decide to reduce it by 60 degrees, then I could describe the angle that is now left over. All right, so in other words, that would be this angle in between over here, right? That is going to be described as alpha minus 60. Okay, so when they say a compound angle, that's what they mean. Okay, so either the sum of two angles or the difference between two angles. That is what we're going to be working with. And we only work with sine and cos, and we are given compound angle formulae. And your teachers at school would have explained to you where these come from. They do or are supposed to do how they are derived. It is extension work. Sometimes it does get asked in exams, but I'm not going to worry about doing that today. I will do that in one of the revision periods that we've got with you. So for now, we just need to accept. All right, cos A minus B, cos A plus B, sine A minus B, and sine A plus B. All right, so when we are working and we are going from the left-hand side to the right-hand side, so if we start with this and we are working towards the right-hand side, then we would call that the expansion of our compound angle formula. All right. If we're going back the other way, then we wouldn't refer to it as reduction. We would refer to it as the reversal of the expansion. Okay, so when we work and we expand it, we're going in this direction. And when we are working with the right-hand side and we go that way, then that is the reversal of the expansion. Okay, so either we can expand these or we can do the reversal of the expansion. And in the beginning, that's exactly what we want to do. We just want to try expanding them and doing the reversal of the expansion and making sure that we've got that down correctly. All right. Note there are a couple of differences here. So if we're talking about cos A minus B, we've got cos A cos B plus sine A sine B. And if we've got cos A plus B, that gives us cos A cos B minus sine A sine B. I always like to tell my students in matric that sine keeps its sign. So sine keeps its sign. So what that means is that if I had a negative over here, I've got a negative over there. If I've got a plus over here, I've got a plus over there. Okay, so sine A minus B when expanded gives us sine A cos B minus cos A sine B, and sine A plus B gives us sine A cos B plus cos A sine B. Right, so in the beginning, all they want us to do, like here in example number 1, is just do the expansion. So we've got to use our compound angle formulae and do the expansion. All right, so if I do the first one as an example, perhaps you guys can try number 2 and number 3 on your own. So they've given us cos x minus y. So now we're going to go and look here. What does it look like? Right? It looks like this one over here where I'm putting the pink star. It's cos A minus B or cos x minus y. So now when I expand it, I'm going to write cos x, cos y. Cos doesn't keep its sign, so this will be plus, and this will be sine x, sine y. And that's all we're doing in the beginning. We'll see later on where we apply these and how we use them, but in the beginning, we just want to become comfortable with applying our applying the expansion and recognizing the formulae. Okay, so if we have a look at number 2, can I have a volunteer, somebody who's willing to tell me what it is they think I should write if I wanted to expand sine A minus 20? Yes, Lusanda, go for it. Sorry, please mute. Thank you. Lusanda, go for it.
Hey, ma'am.
Hi, Lusanda. How are you?
I'm good. How are you, ma'am?
I'm fine, thank you. Do you want to do this expansion for us?
Yes.
Lovely. Go for it.
Ma'am, I think it's going to be sine A cos 20 degrees
Good.
minus cos A
Good.
sine 20 degrees.
Lovely. Okay, very nice, Lusanda. Well done. That's perfect. Good stuff. All right, let's do the next one. Let's have another volunteer who's going to do number 3 for us. Who else would like to have a go?
Hi, ma'am.
Let me just see who's talking. Hang on one moment. Faheen, that does not sound like you. I don't know who it was.
Mila. Mila is the one talking at this
moment.
moment.
Is Mila the one talking? Oh, okay. Yeah. All right. Okay. Mila, do you want to do this one? You're welcome to go ahead, Mila.
Okay. I think Mila just ghosted us.
Oh.
I see Tembile.
Okay.
Tembile and Zinhle are up there. Hello, wanting to answer. Okay, so okay, let's do this. Okay, so I've muted everyone for now, and also Teacher Lee, sorry. Please, you must speak if you have your hand up. Like this, Teacher Lee can see who's talking, and then we can tell you to unmute, because we are all going to talk at the same time, which it's not gonna help us. Yeah. So everyone, you mute. Yes.
Can I try number 3?
Yes, I see your hand was up next, so go for it, Faheen.
It will be sine cos 45.
Cos, good.
Cos
Keep-
45
Yes.
sine to alpha
Okay, so then here there needs to be a plus.
plus yes.
Mm-hmm.
Cos
Keep
2
going.
45
So no, this is going to be cos
cos 2
2
alpha
alpha. Good,
Yes.
good. Keep going. No,
Times
it's okay.
sine 45.
Lovely. Well
Well
done.
done.
Okay, good job. Well done. All right. So now with this particular question, what we see creeping in here are our special angles. And we didn't pay much attention to special angles in grade 11. We did them a little bit, but they weren't really that important. In matric, your special angles are very, very important. And you need to make sure that you've studied them and you've learned them off by heart because you're not supposed to be using a calculator. So let me just move that down and out of the way. And let's just talk about how we would extend this just a little bit further. All right. So if we see the cos of 45 and the sine of 45, we are expected to use special angles in this situation. Does anybody know what the cos of 45 degrees is? Sitimbile, you had your hand up next. Do you know what the cos or the sine of 45 is? Sitimbile?
Tebile is like, I'm not sure. I could read your lips, Tebile. I said, it's okay, but normally you will just unmute yourself, okay? If you want to talk, then you have to press the unmute button. Where it says mute, you have to press it so you can talk to us.
All right. I see Tandalwetu's put something into the chat as well.
Nice.
Ma'am,
Ma'am,
Hi, Lisa.
cos 45 is root 2 over 2.
Is root 2
Ma'am?
over 2.
No.
All right.
no.
It
Okay,
is.
my people, I think I'm going to mute everyone for now. Like, I'm going to just remove that power for you to unmute yourself because it looks like we are all talking at the same time.
All right. So she is right. Okay. There's two ways that we can look at the cos of 45 degrees. Okay. You can write it as root 2 over 2. There's no problem with that. And if you learn a different method, so if you work with the triangles or you work with the fan, then you actually learn it as 1 over root 2, which means the denominator is not rationalized. But it's actually the same thing because when we want to rationalize the denominator, we would multiply this by root 2 over root 2. So we end up with 1 times root 2, which is root 2, and root 2 times root 2 is 2. So to be honest with you, you can use this or you can use this. It actually doesn't matter. Okay, both will be marked correct in tests and exams. Okay, so don't worry about that. What I've also done here is I have written the cos 45 first. You can see I've written it over there, and I've written sine 2 theta at the back. And that's because in maths, we always write numbers in front of letters, okay, or numbers in front of variables. So essentially, sine 2 theta here is seen as a variable. I know it's a trig ratio, but it's basically seen as a variable because there is no value or no known value for alpha at the moment. Okay, so that's why we would write it like that. And we would just leave it like this because there's nothing else that we can do with it at the moment. Okay, so I'd like to give you guys an opportunity just to practice a little bit of this by expanding the ones below. Let's just make that a little bit bigger so that you can all see it. And let's make our compound angles a little bit bigger as well. Okay, so there's a lot here for you to practice. We don't have to do all of them. Okay, so let's pick a couple. Let's try this one. Let's try that one. And then for fast finishes, we can try H as well. Okay, so I just want you to expand them, please. Okay, off you go.
We can do this. Let's go.
I'm just plugging in my laptop. Just 2 seconds. Thanks, Yolanda.
That's okay. Let's go, guys. Rules, 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 rules. Remember, you're just expanding it. So at least you're not solving it, you're just expanding it. And I'm sure it will be quite nice because Teacher Lee has been so nice to us. She has put like all the definitions there for us. So we just have to legitly just expand. I'm telling them that you've given us all the answers. The only thing we need to do is just to follow the rules.
Exactly, exactly. Okay, so I see Faheen and Noctula have put answers in there. In the chat. Okay, so remember, guys, cos does not keep its sign. Okay, sine keeps its sign, but cos does not keep its sign. Okay, I see there's a couple of people with hands up. Sitembile. And then Lisa, I'll take your question afterwards. Sitembile, you're welcome to speak. Sitembile.
There we go. Well done.
Okay. So I'm doing number C, ne?
Mm-hmm.
Okay, so it's gonna be cos 2x cos y
Good.
minus
Lovely.
sin 2x
Yes.
and sin y.
There we go. Beautiful. Well done. 100%. Excellent. Okay, so that's that one done. Nice. Okay, let's see who else has got a hand up. I see Zintle's got a hand up. Zintle, do you want to do E?
There's a pop-up Zintle. Just click on it.
Yes,
There
ma'am.
we go.
So E goes like this. It's gonna be cos 60, cos A plus sine 60, sine Y.
Sign A.
Oh, sorry, sine A.
It's okay. All right, perfect. Did you use special angles?
No, ma'am. You said we
Okay.
shouldn't further.
Okay, so for this one, you can use special angles because you've got cos 60 and sine 60. Zintle, do you know what the cos of 60 is?
I think Zinhle muted herself,
Oh,
and
did
now
she
I
mute
can't
herself?
find her to
Oh, okay.
unmute
All
her.
right.
Yeah.
That's fine. That's not a problem. Okay, let's see if anybody put that into the chat. Oh, and then I remember Lisa had a hand up as well. Lisa, sorry, you did that before anybody else raised their hand. Lisa, did you want to do one of these, or do you know the special angles?
I'm trying to find Lisa. Where is Lisa? Lisa, I found Lisa. Lisa, I unmuted you. You can unmute on your side.
I wanted to give you answers.
Okay, for which one?
For E, C, or
Okay.
H.
Okay, all right. Well, E is incomplete at the moment because we've got special angles in there. Do you want to complete it?
Yes, ma'am.
Okay, go for it.
Okay, so it's gonna be cos 60, cos A plus
Mm-hmm.
sine 60, sine A.
Yes, lovely.
Then it's gonna be half cos A plus root 3 over 2 sine A.
There we go. Lovely. Okay. And Lisa, why can we not add those two together?
Cos is not the same as sine, ma'am.
Exactly. They're not like terms. Okay. Very nicely explained. Well done. That's perfect. All right. Let's see who else has got a hand up. Okay. Omogolo, I see you next in the queue here. All right. Do you want to do cos A plus A for us? Omogolo, you're welcome to unmute and speak.
Yes, please. You have to click on that pop-up. There we go.
Okay, hi ma'am.
Hi, Omogolo. Okay, go for it.
Cos A
Mm-hmm.
minus sine A.
There we go. All right. Can that be
And then,
simplified any further, Omogolo?
yes, ma'am.
Go for it. How would you simplify it?
Cos 2A is equals to
Why? When you say cos 2A, do you mean cos squared A or do you mean cos 2A?
cos 2A is equals to
So unfortunately, when we multiply cos A with cos A, we get cos squared A.
ma'am,
Okay.
I
So,
was going there. You are too fast. It's a
sorry.
double pendulum. Yes.
Okay. So
Double
cos A
pendulum.
times cos A is cos squared A. And then, okay, do the
Minus
second term. Mm-hmm.
minus sine squared A.
That's it. Beautiful. Well done. Perfect. Okay, very nice. Excellent. Well done. Okay, any questions so far, guys? Tandal Wetu's got some good answers. I'm just having a look in the chat. Okay, all right. All looking good over there. Okay, now what we need to do is we need to be able to go back the other way. All right, so now we've got to be able to do the reversal of the expansion. Let me just give myself a little bit more space here. I haven't really given myself enough room to write everything. Okay, let's grab this one and make it a little bit bigger, and we'll pop that on top so that we can still see all of that nicely as we work through these questions. Okay, so this is where things start to get a little bit trickier, Matrix, is that now what they're doing is that they're giving us the expansion and they're asking us to go to the left-hand side. So they want us to do the reversal of the expansion. So now we need to look very carefully at the terms that we've been given. The minute we see sine and cos together, all right, that means we're probably going to be working with a sine compound angle formula, right? So we see sine and we see cos together. So sine 2 theta, cos 2 theta. And then here we see cos 2 theta, sine theta together. So if we go and have a look up at the top there, we see there's a plus here. It looks like this one over here. All right. So in other words, it looks like this. Sine A, sine 2 theta, cos B, plus cos A, cos 2 theta, sine B, which is the same as sine theta. Okay, if we're just working with letters or theta to describe our angle. So now we can see that these two are identical to one another. So that means we're allowed to do the reversal of the expansion. So we can write this as sine 2 theta plus theta. All right, and that gives us sine 3 theta. That's our angle. Okay, if we have a look at number 2, can I have a volunteer to do number 2 for us? Let's see who's got their hands up. Noctula, go for it, Noctula.
You can
You're welcome.
unmute Noctula. It's here. Just click on unmute and then that's it. Okay. I think Noctula is experiencing some troubles. Let me just ask you to unmute. A pop-up will pop in. Just click on it. Could also be network issues, Teacher Lee. Maybe we can
It
just
could be. Okay.
yeah.
All right. Well, I tell you what, let's see if we can help Noctula, or if Noctula can speak again later. Tundle, where to? You next in the queue. Go for it, Tundle, where to? How would you do this one?
Good afternoon, ma'am.
Good afternoon.
Ma'am, we are doing number 2, right?
Yes.
Yes. Would it be cos 70 minus x?
There we go. Good. Well done. All right. So you spotted that straight away. So it was cos, sine. And then, of course, cos doesn't keep its sign. Okay. Fantastic. Well done. That's absolutely brilliant. Let's have a look at, oh, that's a difficult one. Let's do this one next. Okay. So I want to focus on this question, G over here. All right, and let's just see who else has got a hand up. Okay, Sitimbile. All right, you were next in the queue. Have a look at question G. What do you think needs to happen here?
It's gonna be sin 40 4 theta minus 5 theta. Plus it's
Okay,
gonna be minus. Yes, it's gonna be minus.
okay. Now, the reason why it can't be sine 4 theta minus 5 theta is because if you have a look at the first term, it's sine of an angle with sine of an angle. And if you look at the second term, it's the cos of an angle with the cos of an angle. Okay, so if cos goes together, then it has to be a cos
Sine.
compound angle. Okay, but now they've actually, I'm sorry I'm doing this to you. It's not an easy question, this one, because they've actually done something a little bit nasty to us. What they've done, can you see here? All right, is that they've made cos 5 theta, cos 4 theta, they've made it negative. So in other words, if I rewrote the terms here, I would end up with minus cos 5 theta, cos 4 theta, plus sine 4 theta. Oh, sorry, let me rather put the 5 theta first, because that would be the right way of doing it. So sine 5 theta, I'm going to put that over there, and then I'm going to put sine, let me just move this over a little bit, sine 4 theta over there. Now, I've just switched the order of these two around, okay, in this term over here. I'm allowed to do that because the order in which I multiply doesn't matter. So if I say 2 times 3 and Omoholo says 3 times 2, we're all saying the same thing. All right, so the order in which we multiply these two together does not matter. All right, so I've taken the first term and I've written it in the first place, and the second term, and I've written it in the second place over here, right? So I've got cos first and sine second. But there's a problem. This minus is a problem for me, okay? I cannot do the reversal of the expansion until I have dealt with this negative. So I'm looking for somebody to tell me what it is they think I should do with my negative. Sharon, do you know? You had your hand up a little while ago. Do you know what to do with this negative? Ah, there we go. So Tundle where to and Latani. Okay, that's fine, Sharon, not a problem. They have said take out our negative as a common factor. All right, Tundle where to? Brilliant. Okay, so we're going to take out the negative. We're going to factorize it out matrix. So I'm going to take it out and I'm going to use brackets. So inside we've got cos 5 theta, cos 4 theta. And if I want a plus here, I need a minus over there because a negative times a negative is a positive. So this gives me sine 5 theta, sine 4 theta, like so. All right, so my ratio is going to end up being negative. Now I can go back and I can look at my compound angle formulae and I can say to myself, what does it look like? It's cos, sine, right? And I know that cos does not keep its sign. So it looks like this one over here. The one that I'm highlighting in pink. Okay, because I've got cos, cos minus sine, sine. All right, so someone finish this off for me. What do you think I should write? Tundle, where to go for it?
Ma'am, should I
Yeah.
carry on from where we left
Yes,
off, or
please
should I-
do. Yes. No, no, no. You're welcome to carry on.
Okay, I have negative in brackets cos 5 theta of cos 4 theta minus sine 5 theta, sine 4 theta and sine 5 theta. And then my next step is negative cos of 5 theta minus 4 theta, which will give me negative cos of theta.
Okay, you're almost 100% correct. All right. The problem is that the cos compound angle does not keep its sign. So if you have a look at what I highlighted in pink over here, okay, there's a minus in the middle here. There's a minus in the middle here, but here there is a plus. Okay, so this is going to end up in brackets. This is going to end up being 5 theta plus 4 theta, like so. Okay, which gives us a final answer of negative cos 9 theta. Let's just write that a little bit better. It doesn't look like cos. Okay, 9 theta, like so. All right. Okay. There we go. All right. So question G was just a little bit more difficult, but it's important that you guys see these things because these are the sorts of questions that you are going to be exposed to. So just to emphasize again what it is that I have done over here. All right. We have done a switch round. All right, which is something that we've seen before when we were in grade 9, grade 10, etc., etc. So in other words, if I have an expression like x minus y, and I want to take out a negative, all right, for example, let's say I have negative x plus y. Let's say I've got that. If I take out negative 1 as a highest common factor, then x is going to change its sign inside the brackets because a negative times a positive is a negative. Then my next sign over here also needs to be a negative because a negative times a negative gives me a positive. All right, so minus x plus y is the same as minus 1 times, in brackets, x minus y, like so. All right, so that's essentially what I've done. I've done an algebraic manipulation here because I want the cos first and the sine second so that it looks identical to the expansion of my compound angle formula. So I can go ahead and go and do the reversal. Okay, favor, why can you not divide it through by negative 1? Very good question. I'm so glad you asked that. Why can we not divide through by negative 1? Anybody know why? Why can we not divide through by negative 1?
Eddie's hand is up.
Oh, Teddy, go for it, Teddy.
No, ma'am, I wanted to ask something, but I will ask when ma'am finished explaining this.
Okay, all right, that's absolutely fine. Okay, so the reason I cannot divide through by negative 1 matrix is because this is an expression. It's not an equation. I'm not solving for theta. So, for example, right, if I said to you factorize, and the expression that I gave you to factorize was x squared minus 3x plus 2, for example. All right. You could factorize that. So minus 2, minus 1, and that would be factorizing. If I want to solve something, all right, then it has to be equal to 0 if I want to divide through by negative. It needs to be an equation. So if I change the signs here, all right, so let's pretend now that that becomes negative, this becomes positive, and that becomes a negative over there. All right, and I said to you, factorize this. You cannot factorize it by dividing through by minus 1. If they said to you, solve for x, and you had minus x squared plus 3x minus 2 equals 0, then you can divide each term by -1. But if you are factorizing, you could only take out a negative, all right, because it's an expression, it's not an equation. All right, so you can't divide through by -1. Okay, so I see there are a couple of hands up. Teddy, you're welcome to ask your question, and then Zintle, I'll take yours after that. Yes, Teddy.
Ma'am, what confuses me, ne? Cos bracket A plus A is not equal to cos bracket 2A, right?
Just say that again, cos
Bracket A plus A is not equals to cos bracket 2A.
No, it's not. Yes, it is. Yes, it is. Yes, it is. Yes, it is. So
Is
cos
it?
A plus A, yes, absolutely, is equal to cos 2A. Absolutely.
Oh,
Absolutely it
so
is. Yes, it is. That's a
so
double angle. Yes, yes, yes. Yes, yes, yes. Yes,
okay.
yes, it is. 100%. You're quite right. I'm just not talking about double angles yet. We're doing the compound angles first, but yes, you're absolutely right, Teddy. Cos bracket A plus A closed bracket is cos 2A. Quite right. Okay, no problem. And then there was Zintle. Okay, Zintle, go for it. What did you want to ask?
Oh, ma'am, I really apologize for making you go back, but I would really like you to explain number 1 again, please.
When you say number 1, do you mean the very first example that I did? This one over
Yes,
here?
ma'am.
Oh,
Yes, ma'am,
okay.
that one do.
All right. Okay, so let's just go back and have a look at this. All right. What I wanted you to see here, Zintle, all right, was that cos 2 theta cos theta plus cos 2 theta sine theta is identical to what we see over here, all right? Because we've got sine A, sine 2 theta. Then we've got cos B, which is cos theta. Then we've got a plus sign. Now that's very important because we can't ignore that either. So here we have a plus sign. All right. Then we have, let's just change our colors. All right. We've got cos A, which is the same as cos 2 theta. And then we've got, let's use another color. Let's go with orange. We've got sine beta over there, and we've got sine theta over here. Okay, so in other words, number 1 is identical to this sine compound angle formula. Okay, what we are looking at is the expansion. All right, so what we want to do is go from here and go back the other way and produce this over here. Okay, so there's no factorizing that needs to be done. The terms don't need to be switched around. It looks absolutely identical to my compound angle formula. So now I'm allowed to write this as sine brackets 2 theta plus theta. And then I'm going to add together my like terms, and that's going to give me 3 theta. Okay, does that make sense now?
Yes, ma'am, thank you.
Okay, all right, no problem. So let's go down here and let's have a look at these. Now, I wouldn't be very nice if I didn't give you this. Let's just pop this on the side. Okay, can go back again. There we go. We'll move this over here and we'll stick that up there. And now hopefully everybody can see all of this fine. Okay, so here we want to write as a single trig ratio. So in other words, we are writing the reversal of the expansion. So what we have on the left-hand side of the equal sign, that's what they want from us. Okay, so I've given you questions A, C, and E. Let's try those and then we'll talk about our answers. Okay, Matrix, off you go.
Teacher Lee is being nice with all of us, guys. We have the answers right there. We do.
We do. Okay, so everybody continue working. I'm going to just take a couple of questions. You can continue to work. It's not a problem. Vusani, you've got your hand up first. You want to ask?
Ma'am, aren't we are dealing with compound angles, ne?
Mm-hmm.
So if we were dealing with compound angles and then we found ourselves, we found ourselves having a double angle, while solving the equation given. So do we also attempt the double angle or do we exclude it?
No, you would. So you would end up working with the double angle as well, absolutely. But at the moment we're not doing questions that are that complicated just yet. But yes, you would end up doing that. You would end up having to then work with a double angle and manipulate it in some way in order to get to an answer. So yes, you would do that. Okay.
Okay.
All right, no problem. Noctula, do you want to ask as well? You're welcome to ask, Noctula. Okay, so Lisa's done, Faber's done, Zintley's done, Tina's done. Good, nice. Okay, you guys are doing this quickly. Very good. Well done. All right, Amu's done, Kamachelo's done. Good job. Okay, Noctula, if you do want to ask, you're very welcome to put your hand up again. Okay, so let's have a look. All right, so in question A, who said done first? Okay, Luam's done. Oh, wow, there are a lot of people that done. Okay, Lisa, you were the first person to say done. So what did you write for A, Lisa?
Okay, so when I wrote cos 3 theta plus sine 3 theta sine theta is equal to cos 3 theta minus theta.
Cos 3 theta minus theta. Okay, so I'm just going to
Yes,
catch up with what
equal
you were
to
saying. Okay, and you said that that was equal to cos?
cos 2 theta.
There we go. Lovely. Perfect. Well done. Excellent. Okay, Favor, you had your hand up next. You do see for us, please, Favor.
Ma'am, so I had sine 4p and then cos 2p minus cos 4p and sine 2p.
Lovely.
It's equal to sine, open brackets, 4p minus 2p, close brackets. And the answer is sine 2p.
Lovely. Oh, you guys are amazing. Well done. Good job. Good job. All right. Fantastic. You are. Okay. And Zintle, your hand was up next. Do you want to do E for us?
Yes, ma'am.
Go for it.
So the answer to sine 3x times cos x minus cos 3x times sine x is equal to sine, open brackets, 3x minus x.
Yes.
Which will then give you sine 2x.
Beautiful. Okay. Fabulous. Nice. Good job, everybody. That's excellent. Brilliant, brilliant, brilliant. Well done. Okay. So now that we've practiced doing the expansion and the reversal of the expansion, let's just have a look at a couple of questions that they would expect us to be able to answer where we're now actually working with values. All right. Now, remember, they are very fussy when we are working with trig expressions. We are not allowed to use a calculator. All right. You guys are doing absolutely brilliantly. I'm so excited. I'm so glad that this is making sense. I'm just going to put that to the back and bring this up here. Hang on. There we go. There we go. And then at least we can stick that there out of the way. Hopefully it's big enough. You guys can see this. I'll just try and expand that a little bit. Okay, let's have a look at number one. And then when I've done number one, we'll see if you guys can try number two. I know that these are a little bit more challenging. But just hang tight and let me explain number one first, and then we'll see where we go. Right. So the first thing that we want to establish here, all right, is where we have angles that are either reflex angles or obtuse angles. If we are dealing with angles bigger than 90 matrix, we use our grade 11 reduction formulae, the same ones that we were talking about on Tuesday, in order to write all of these angles as acute angles. So let's just get this down. Cos 320 cos 20 minus sine 140 sine 200. Okay, so I'm focusing on the cos 320 because that is a reflex angle. 320 is in quadrant number 4. Okay, so we're going to use the reduction formula, 360 minus. Okay, so this would be 360 minus 40. Okay, so I'm going to write this as positive cos 40. Cos 20 is not a problem for me. And now here, both of these are bigger than 90. So again, I've got to use reduction formulae. 140 is in quadrant number 2. So I'm going to use 180 minus. So that is going to end up being positive sine 40 degrees. Okay, and then as far as sine 200 is concerned, 200 puts me into the third quadrant, so that would be 180 plus. But sine is negative in the third quadrant, so this becomes negative sine 20. Okay, now I've got to deal with the fact that I'm multiplying a negative and another negative together. So in my next line, I write cos 40 cos 20. A negative times a negative is a positive, and that gives me sine 40 sine 20, like so. Now that I've got cos, sine, sine, I'm going to go and look at my compound angle formulae, and I'm going to ask myself, which one is this like? So now I'm using the skills that we practiced in the previous section, all right? And I can see that it's like this one over here. Okay. Oh, sorry, I underlined the wrong one. Beg your pardon. Okay, I can see that it is like this one over here. Cos A, cos B, plus sine A, sine B. So when I want to do the reversal of the expansion, that's what I've got to do. Okay, so now doing the reversal of the expansion, I am going to end up with cos 40 minus 20. So this is going to give me a final answer of cos 20. All right, and I cannot do anything else because I'm not allowed to use a calculator. This has not ended up being a special angle, so I would just leave my answer like that. Okay, now I can see there's a couple of hands that have gone up, so let's just give people an opportunity to ask questions. Okay, Favor, what did you want to ask?
Sorry, Teacher Lee. While we're doing that, we can scroll up. Michaela wants to take a screenshot at the up there. Sorry, Favor. Apologies.
We're here.
Yes.
Oh, okay. All right. I'll stop there and we can do a screenshot and I'll come back down again.
Thank you.
Okay. Mikhail wanted a screenshot. Oh, okay. All right. There we go. Hopefully, Mikhail, you've had a chance to do that. So coming back down here, are there any questions, Matrix?
Yes, ma'am, I have a question.
Go for it, Favor.
Ma'am, for the sine 200, wouldn't it be okay for me to write down sine 180 plus 20?
Favor, there's nothing wrong with you doing that, but that is not a step that you need to show. But if you want to do it, you're more than welcome. Okay, but that is not a step that you have to show. So you don't have to show which reduction formula you're using, but you have to show what you get as a result of using a reduction formula. So that's why I've written cos 40, sine 40, and minus sine 20. Those things I have to show.
Yes, ma'am, I'm asking because I would find it a bit confusing with the negative sign 20 and then having to change the signs again to positive.
Absolutely, absolutely. So if you want to include an extra line of working here, that's not a problem at all. Okay, so essentially what we would have is that in here we would have an extra line of working. So what you could do is you could say cos 320. So this would end up being 360 minus 40. And then cos 20 wouldn't change because we don't need to reduce it. And then as far as sine 140 is concerned, that would be 180 minus 40. Let's just move this over a little bit. Okay, and then as far as your sine 200 is concerned, we would end up with sine 180 plus 20, like so. Okay, absolutely nothing wrong with that.
Thank you, ma'am.
Pleasure, no problem at all. Okay, so these things you're not going to get marks for, all right? As I was saying, it doesn't matter that you show them, but over here you would get a mark for that. Okay, you'd get a mark for where you reduced. Okay. All right, and then obviously here there would be a mark for making sure that your sign had changed, and then that you had done the reversal of the expansion in the correct way. Okay, any other questions that you want to ask at this point, Matrix? Are we all good? How are we feeling, by the way? Sorry, I haven't even checked in with you guys today. So far, are we all good?
Wow.
Oh, that's nice to see. So we've got 2 thumbs ups. How's everybody else feeling?
Well, we added Valentia's hand is up. I'm not sure if it's for a question.
Mbalenhle, go for it. What was your question?
Hi, ma'am.
Hi, Mbalenhle.
I'm sorry, can you just go back a bit? I'm a bit lost on how you came about with the cos for
The cos? I seem to have lost you, Mbalenhle. Okay, so what I'm going to do just in the last few minutes that we've got, I'm going to get you guys to try one as well. Okay, so here we go. We're not going to be able to do all of these, unfortunately. Time is always our enemy, isn't it? We just never, ever have enough time. Okay, so let's just make those a little bit bigger. Okay, I would like you guys to try. Okay. A is very easy. Let's try question C. Let's try question C. And then we have an opportunity to practice our reduction formulae as well.
And it's the last question of the lesson.
It is. It's going to have to be, unfortunately. Omogolo, what do you want to ask, Omogolo?
Ma'am, I wanted to ask about the previous class question.
The previous class?
Yes.
Okay, you mean the one that we had on Tuesday?
Yes, ma'am.
Okay, what did you want to ask? So everybody else carry on working. Omogolo, ask your question.
Ma'am, I have last year June mathematics paper 2. And then they give us a a sum to solve. So in that sum, we had, I've lost the question. Let me find it first.
Okay. All right. Find the question paper so long. Oh, wow. Favor's done already. Oh, my word, Favor. That's excellent. Well done.
Charlie, I'm not sure what you suggest. Should I then, because I see it's now 55, should I then, I'm just going to send them
Yes.
the link for the quiz, and then you let
Yes,
me know
do
if I should
so.
log out before you'll just let
Yeah,
me
I
know.
think it's probably a good idea. I see Luam's also done. I'm sorry, guys. I know we're running out of time. I'm so sorry. I wish we had longer in these lessons.
Yeah. So should I log out then and join
I
the
think
other lesson for
you
you?
go and log out, join the other lesson for me, and I'll be there right
Okay.
now. I'm just going to finish this up.
Okay.
Thanks,
Teacher Lee.
Yolanda.
Bye, teacher. Enjoy.
Bye, Yolanda. Thank you. Okay, Kamogelo's done. Good.
Ma'am, I found the question.
Okay.
It's question 3, and then the question says, if cos 35 is equals to P without using a
Yes.
calculator,
Yes.
determine the following in terms of P. So
Yes.
there's no restriction where we should start and end in the between 0 and 360. So I was asking if it's like this, how would we do it?
Okay, so because this is an acute angle, you have to be working in quadrant number 1. So there would be your angle of 35 degrees. I actually wanted to do one of these with you guys the other day. All right. And then what you would end up doing is you would end up interpreting P as P over 1. The cos of any angle is X over R. So that means that R is equal to 1. And it means that your X coordinate is equal to P. And then you'd have to use the theorem of Pythagoras to calculate your Y coordinate. Okay.
Yes, ma'am. Okay, I
All
just
right.
wanted to know where would the quadrant be?
Yeah, no, it would be in quadrant 1. It's an acute angle. That's not a problem. Okay, so it seems as though a lot of people are done, which is really, really good to see. Let's just quickly go through this. And then unfortunately, I have to skedaddle to the other question. You guys are welcome to take a screenshot of this. If you want to try these questions, that's fine. We can always talk about the answers at the beginning of our lesson on Tuesday. I hope you guys are all going to be there. Okay, so if we're talking about an angle that is 280 degrees in size, we've got to be in quadrant number 4. So that means we're going to use 360 minus, okay? So this is going to end up being the sine of 360 minus 60 would give us 280. So this is going to end up being sine 60. I suppose we don't really need the... Did I make a mistake there? Hang on. 360, so that'd be 60 plus 20. Oh, sorry, it would be sine 80, wouldn't it? I'm sorry. Sorry. Sine 80. All right, then cos 160 is going to be in the second quadrant. Okay, so this is going to reduce to negative cos 20, like so. All right, then cos 100, that is also in the second quadrant. So this is going to reduce to cos negative cos 80, and sine 200 is in the third quadrant. So this is going to reduce to negative sine 20. Okay, so we would end up with that. So in our first term, we have a negative times a positive. That gives us a negative. So we've got negative sine 80 cos 20 minus, and then a negative times a negative is a positive, and a positive times a negative would be a negative. So this would end up being cos 80 sine 20, like so. All right, so now we've got sine cos, cos sine. The problem is we've got the negative over here, so we would have to take the negative out. We would have to do our switch round like we've spoken about before. And then we would end up in brackets with sine 80 cos 20 plus cos 80 sine 20. Our ratio will be negative, and because it's sine, cos, sine, it's sine. Sine keeps its sine. So then we would end up with the sine of 80 plus 20, which would be sine 100. Okay. And that would end up being our final answer for this one. Have I made a mistake here?
Sorry, ma'am, for being rude.
No, please go right ahead.
I think there's a mistake by
Yeah,
sine
I'm also
80. It's supposed to be minus sine 80.
in which line?
By the first
Oh,
one.
yes, of course. No, you're quite right. So that's also negative. So that ends up being a positive. Okay. All right. Sorry. I also figured I had made a mistake when we weren't able to evaluate it properly. Sorry. You're quite right. That would end up being a negative.
No,
Sorry. Silly me.
this is an
So now a negative times a negative would give us a positive. Quite right. And then negative. Okay, so that is correct. Okay, there we go. That's better. So now we're going to end up with sine. Sine keeps its sign. So that would be 80 minus 20. So that would be sine 60. And the sine of 60 is root 3 over 2. Okay, and that would be our final answer. Okay, matrix.